Hi, our lesson now is about exponential and rational functions. Let's start by the exponential function. The exponential function has the general form f of x equal to a to the power of x plus a constant. Let's sketch a function to see the general shape of the function. Let's sketch f of x, which is equal 2 to the power of x plus 3. Let's draw our axis first. We have to go to our graphical display calculator to see the shape of the function. We go to graph. Let's just clear everything. And I sketch 2 to the power of x plus 3. Let me fix the V window. I want to have it as standard from -10 to 10 and from -10 to 10. And then I draw. I have the shape of the function having this way. So the shape of this function has this way. This is 2 to the power of x plus 3. I have a horizontal asymptote here. This is a horizontal asymptote. The horizontal asymptote, it means as the function goes very large or very small, it will never touch or cross this asymptote. Always, the horizontal asymptote for the exponential function is always equal to the constant. So the equation of the horizontal asymptote, simply y is equal to the plus c. In our case, the 2 to the power of x plus 3, the equation of the horizontal asymptote is the plus 3. So the equation of this horizontal asymptote is y equal to 3. This is the general shape of any exponential function. Let's have an example now. The temperature T of a cup of coffee is given by the function. The temperature T with T in minutes is equal to 18 plus 60 times 2 to the power of negative T, where the temperature is measured in degrees Celsius and the small t, which is time, is measured in minutes. The first part of the question, we need to sketch the graph of the T of T for the domain of T from 0 to 10. Now, to have our graph, first we have to figure out what's the equation of the horizontal asymptote. So in our case, I have the constant to be 18, so I can know that the equation of the horizontal asymptote y is equal to 18. After figuring out the horizontal asymptote, we can sketch the graph. So to sketch the graph, I have my axis. I have the horizontal asymptote to be y equals 18. Let me draw the horizontal asymptote in blue color and green color. This is the horizontal asymptote, which is y equal to 18. Now I need to sketch the function from t from 0 to 10 only. So I go my graphical display calculator, exit. I plug in the function in here, it's 18 plus 60 times 2 to the power of minus t, which is minus x. And I need to fix the v window. So I go to shift v window. The x minimum must be 0 because t lies between 0 and 10. And the t maximum is 10. I go to fix the y because the y won't be negative, and the maximum y, let it have it to be 100. And then I simply draw. So I have the function having this shape. So my function will have this shape. It will never touch the horizontal asymptote. For part B, we need to write down the temperature of the coffee when it is first served. So for part B, when it is first served, this means that the value of T is 0. So for part B, I need to find the temperature when the value of small t is 0. This is equal to 18 plus 60 times 2 to the power of negative 0. And this will give me, we can find this value directly from the graph. How we can find it? We go to Shift G solve and I go to y calc because I have the x value, which is the t value small. I need the temperature. I go to y calc. The calculator will ask me what's the x value or the small t. It is 0. So I want to find the value of the temperature when x is equal to 0. Then I will have the temperature, which is the y value, is equal to 78 degrees Celsius. So this is equal to 78 Celsius. Part C. We need to find the temperature of the coffee after 5 minutes. After 5 minutes, this means that the value of small t is equal to 5, which is equal to 18 plus 60 times 2 to the power of negative 5. This will be equal to, I can use the run matrix if you like. It's 18 plus 60 times 2 to the power of negative 5. And this value will give me 19.9 degrees. Part D, we need to calculate the number of minutes that it takes the coffee to reach a temperature of 40. Now, the function, all of the function has a value of what? 40. So now, in order to solve it, I have to substitute 40 instead of the value of the function. So I have 40 is equal to 18 plus 60 times 2 to the power of negative t, having the small t to be unknown. If I have an equation with one unknown, I simply can use the solver of the GDC to find the value of small t. So I start my graphical display calculator, I go to menu, and I press equation, and I go to F3, which is the solver. Let's just delete the previous work. I have 40 is equal to 18 plus 60 times 2 to the power of negative x. And then I have, press solve again, I have the value of small t is equal to 1.45 minutes. So the value of t is equal to 1.45 minutes. Let's do part E now. Write down the temperature of the room where the coffee is served. As you know, the coffee will lose temperature to the room it will keep losing its temperature to the room until its temperature becomes equal to the temperature of the room. It becomes equal to the temperature of the room after a very, very long time. And when I ask for a very, very long time, I go for the asymptotic behavior. So, as the function for a very, very long time, what does this function approach? It will approach the value of the asymptote. So now, for part E, I can see that the temperature of the coffee will keep approaching the value of asymptote, will approach the value of asymptote, of the horizontal asymptote. So the temperature of the room is simply equal to the value of the horizontal asymptote, which is equal to 18 degrees.